Hello. Has anyone ever been or is affected by sunlight and and sneezing when going out in sunlight? Yep, that's what I feel like right now. I'm really scared that I might sneeze. Sorry if I do. So I'm Lynn Root from San Francisco. I just want to give a quick shout out to the PyLadies auction, which happens at 6:30 tonight upstairs in 710B. We have a lot of awesome awesome items up for auction, and even if you aren't going to buy anything, even if you didn't get your company credit card, it's okay. It should be fun. So I hope to see you there. I will be an auctioneer, so it should be fun. We're running a little bit late, but we'll just go right ahead and start. This is Sarah Guido from Ann Arbor, Michigan.
All right. Hi, I'm Sarah Guido, and I'm here to tell you to choose pandas. So, a little bit about me briefly. I'm a data scientist and a PyLadies organizer, and I use lots of Python all the time, including pandas. So, what is pandas, if you haven't figured that out from the dozens of pandas talks here at this conference? Pandas is a Python module used for data analysis and modeling. It's similar to R in Excel. In pandas, you could implement easy-to-use data structures like the data frame, which is a pretty core feature of pandas. The data frame represents a table of data and is also similar to R's data frame. Pandas comes with many data analysis tools. So you can merge and join data frames, you can pivot them, you can run aggregate functions, you can visualize data, and there are many more tools, more than I can possibly cover in 5 minutes. So why would I want to use pandas? Well, whenever I can keep everything in Python and not have to switch between Python and a tool like R or Excel, that just makes it easier for my data analysis pipeline. Also, pandas is actively in development, and the documentation is wonderful. There's a lot of community support for it, again, as you probably have seen from this conference, and there are a ton of great resources for learning pandas. There's a great tutorial on the site. I know Julia Evans has a wonderful pandas cookbook GitHub repository, and there's a great book, Python for Data Analysis. Pandas is great for data preprocessing, analysis, and visualization, and especially for data preprocessing. So I'm going to give a very brief, very simple example on how to use pandas. I'm just going to read in some data, analyze it, and then create a visualization. So first thing we do, we import pandas as PD, which is a standard convention. And then to read in a CSV, you just use the read CSV file. It's really easy. You just pass it in your file, and boom, you have a data frame. You can see along the top, those are the column names, and then our data, the first 5 data instances. So no hassle, very easy. So the data set that I'm using is a car evaluation data set, which evaluates cars based on a variety of criteria, like the size of the trunk, the number of doors, the number of seats, etc., and then gives each car a rating of either unacceptable, acceptable, good, or very good. So it's basically how good the car is. So let's say we wanted to look at the average number of doors per trunk size rating combination. So we can do this with the pivot table function. So we set our values equal to the number of doors, the doors column. We set our rows equal to the size of the trunk, so the lug boot column. We set our columns equal to the ratings, which is the class column. And then our aggregate function will be the mean. So after running this, you can see each of the different combinations. So for example, the average number of doors that a car with a trunk size of big and a rating of acceptable has is 3.5 doors, which is kind of silly, but. So you can also see that the small, very good combination, the trunk size small and then very good rating combination has not a number for an entry in that little table there, so there's no data for that. So this is interesting. So let's take a look at the distribution of ratings in the data set. So we want to know how many of each rating instance exists within this data set. So it's really easy to not only get value counts from a data frame, but to also plot them. So we can access the rating column on the data frame through an index. So we have our car eval data frame, and then we just access it with the index of class. And then we can run our value counts function on that. And then this will return the number of instances that have the unacceptable, acceptable, good, and very good ratings, and Plotting that is really easy. We just use the plot function. I've chosen to do a bar plot here. And you can see that we have a very uneven distribution of ratings. We have about 1,200 unacceptable ratings, and then very few good and very, very good instances. So that's kind of interesting. And that's just a very simple example, one that I could do in 5 minutes. So how would you implement pandas in your data analysis workflow? Well, you can, for example, use it for preprocessing. You can use it for reading and writing files, for cleaning your data. Pandas has a lot of great functionality for handling missing values. You can use it for manipulation. It's also easily combinable with other modules like scikit-learn, NumPy, and SciPy, and Matplotlib, and that's usually how I use it. So this is my Twitter handle. Thanks very much for listening. Hope you enjoyed it.
Thank you, Sarah. Okay, so we have Jyrki Pulianen setting up over here. We have Tendai on deck to set up here after we hear from Greg Ward, who's going to be teaching us about writing great commit messages.
Thank you. Okay, okay, good, the mic's working. Yeah, like it says, all about documenting history, the fine, unappreciated art of the commit message. So what is a commit message for when you save something in your version control system? Well, the real question is, what is version control for? Why do we use version control? And there are a bunch of reasons. It's a cheap and cheerful backup system. More importantly, it lets you save that code that you just got working now. It also lets you save that version that you're about to release to your users, or maybe just to yourself if you're the only user. And finally, most importantly, it's a tool for collaborating with other people, team members or people around the world. But really, those 4 reasons boil down to 2 important reasons. That using version control as a backup is a hack. It's really about helping your memory, helping you remember stuff, either on a short time scale of hours and days or a long time scale of months and years. And it's about collaboration with other people. So fundamentally, there are 2 things that version control buys us. It reminds your future self why you made that change that you just made. Think of yourself in 6 months or 3 years. And it tells your colleagues right now why you made that change that you just made. If you put those 2 together, there is a composed feature, which is that version control tells your future colleagues, people you might not even know yet, or your successors, people you might not ever meet, tells them why you made that change. The common thread connecting all these things, why you made that change. That's kind of important. A good rule of thumb when you are writing software or comments or doc strings or commit messages is to assume the person who will be maintaining your code 2 years from now is an axe-wielding maniac who knows where you live. So really, what I want to see in that commit message, please, 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 please tell me why you made that change. If you like, you can throw in a little information about what change you made, especially if it's a big change that's not entirely obvious from the diff, but tell me why. So please, let me introduce Greg's rules for writing great commit messages. Number 1, tell me what you did and why. Very often, what you did is obvious from the diff. I don't need to read English prose to say rename foo to get foo. That's right there in the diff. It is much more interesting to know why you did that rename. Was it to conform to our team's coding style? Was it for better clarity? Was it just on a whim? Brevity is the soul of wit. If I wanted to read a novel, I'd read a novel. If you want to write a novel, that's great. I really encourage your artistic ambitions. But keep it out of the commit message, please. That said, I'd rather have too much information than too little information. So if you don't have the time to write a short commit message, that's okay, I'll accept a long one. Pick a style, stick with it. If you want to write real sentences with initial caps and verbs and articles and prepositions in all the right place in a trailing period, great, I thoroughly encourage that. If you just want to do telegraph English or headline English where caps don't matter, prepositions get dropped, no trailing period, that's okay too, just do it right. Pick a grammatical mode. You can use any grammatical mode you like as long as it is the present tense imperative. Every open source history I've ever looked at, pretty much all the commit messages sound like this. If you think about the semantics of the grammar, it's actually a little bit weird. It's as though you're commanding the code to change, or you're ordering some strange godlike entity to modify the code on your behalf. Who's going to replace IO error with OS error? It's a bit weird, but that's really the most common style. I've seen people in sort of proprietary internal corporate software using the past tense sometimes, or the present tense. I get it, I understand what they're saying, because it's kind of what they did, but really it's a weird style. It's really not something you see very often in open source projects, because we do ruthlessly enforce these things. Spelling counts. And so does grammar, and so does punctuation. Just like in your comments and your doc strings. Don't laugh. Just like in your comments and your doc strings, you should write full sentences. Or not. Or you can write telegraph English if you like. Just be consistent and comprehensible. Use punctuation. Spelling counts. And most importantly, teamwork counts. You are not working alone. You are part of a team, and all of your team should follow the same rules. Above all, tell me why you made that change. It's okay if you tell me what, that's great. Tell me why.
Thank you. Thank you, Greg. Okay. So we have Larry Hastings setting up over here on Jake Vanderplaza's laptop. We have, pardon me, now we still have Tendai on deck, and I'd like to introduce Jurgi to speak to us about DH Virtual Env.
So, hello everyone. My name is Jyrki Pulliainen. I come from the faraway land of Sweden. Because this is a Python conference and you never talk about packaging in Python conference, so I thought about chipping in with the one more talk about packaging, about the tool that I wrote to solve a few problems called DH Virtual Env. But before we look deeper into the tool, what it contains, let's have a short quiz. Who here runs Debian or Debian Derivate like Ubuntu in production? Yeah. Who here uses the native Python packages on those platforms? Yeah. Who runs like pip with virtualenv and all kinds of magic in there? Yes. Yeah. Well, if you run the native packages, you probably like, okay, they've been there, they're like battle tested by Debian, but they can be old. Like you run into a bug and you find in that, oh, someone has fixed my bug upstream. Like, oh, I'm running request 1.3 and 1.3.1 has fixed this bug upstream. And then the kind of like the reality kind of hits you. If you're going to wait Debian to package it, this will happen. OK, so you get burned by this. Fine. You think about, I've heard about this cool tool called pip. And I'm just going to install stuff with that one on the disk. But then you kind of realize that that's probably not a cool idea, because you probably break something on the way. Or you start backporting stuff yourself, which is even worse. And then you hear your neighbor that, hey, we run pip plus virtualenv on the host. And you're like, damn, this is a really good idea. And you SSH your host, you build your virtualenv, you pip install everything. You're like, god damn, I need this gazillion development headers. So you start installing all these development headers on your box until you run out of disk space or something. Anyway, you litter your box completely. Maybe someone tells you to use Fabric or like set up this all in Puppet, but it won't still kind of get rid of the idea that you have to have all kinds of development headers. You have to have like a build dependency on your production host and stuff like that. So at Spotify, where I work, we still use partially like the operating system packages, but I thought like there must be a better way to do this. So whoops, sorry. So because my heart bleed when I thought about this Debian stuff. It's like, it's not like, like backporting stuff won't go through. So I thought, like, why couldn't I like marry those two? Why couldn't I take the virtualenv, and then we have this amazing Debian build architecture, so I could just cram in the virtualenv into the Debian build architecture, which we already run, and then make it somehow packaged in a neat way that you have a build server that does your virtual env, installs all the dependencies in there that you need, and then you create this nice Debian package. So I went to read a ton of PERL files, like a ton of PERL files, which is the Debian packaging parts. And I even found out that they have actually written the Debian packaging. So they have it's mostly PERL, but they also have implemented parts of it in Python, which was kind of nice. So I went in and created a tool called dhvirtualenv. And as I said, it's basically make a virtual env, install all your dependencies in there, read them from requirements.txt, then cram it in the Debian package, do some shebang fixing that, if you run those scripts directly, they pick up the correct Python interpreter, and then you just ship it on the host. The bonus here is that you can define, like, if you need C libraries or something like that, you can use the basic Debian control file thingy to do it. But even if you wouldn't know anything about whatsoever Debian packaging, it's fairly easy to do. So you create some magic Debian files, like compat. Every guide says like echo number in the compat file. Sounds reasonable. Then you scrape internet. You find a control file. You paste it there. You can use this one if you want, but not necessarily every one of you is called mat maintainer. You add a changelog entry, you do all this, you add a rules file. So this is basically what tells the Debian that, hey, we want to build this stuff in virtual env. But the best part is that you don't really need to worry about this one. Like now, we've done that one once, and then you can just build packages. And even if you don't have the world's best like a photo memory and you can't remember my guides, this tool actually has a comprehensive documentation with tutorials. It's open source. I'm kind of running out of time. It's open source. It's GPL version 2 or newer, because all the build tools kind of are that, and I have to rely on that one, but it won't taint your code, rest assured. And all that stuff is available here. So if you're into having some better way of packaging stuff on your Ubuntu or Debian box, give it a look. We run it in production, works like a charm, even though I'm saying it. It has a documentation with tutorials, and if you want to reach out to me, that's my Twitter handle, or just like come poke me in here. Thank you.
Thank you, Jyrki. I just wanted to introduce myself again. My name is Hai Karel. I want to thank Lynn for setting up all the talks and introducing the speakers tonight. She had to run off to take care of the PyLadies auction. We have on deck, we have Jason Gores, and setting up over here, we have Tendai. I also just wanted to tell you a story about two fermions that walked into a bar. One of them ordered a martini, vodka martini with a twist. The other said, darn it, that's what I was going to order. So then also, what did the logician say when she was asked if she likes Python or Ruby? Yes. Okay, without further ado, we have Larry Hastings telling us things we didn't know.
Okay, ladies and gentlemen, boys and girls, children of all ages, this is Things You Didn't Know. The idea here is that I'm going to tell you N things. I'm not actually sure how many it is, and I'm hoping that there will be at least 2 of them that you didn't already know. So we're going to go really quick because I have to pack in my 5 minutes. So first, command line quoting. If you want to call a subprocess, you might have a list or you might have a string containing the command line that you want to run. Happily, subprocess.popen will accept either one. But what if you have one of those and you want to turn it into the other one? Well, if you have a list and you want to turn it into a string, that's kind of easy. There's a function in 3.3 and above called shlex.quote. Below those, there is something built in. It's hidden. It's not publicly documented, but you can get away with using it. It's called subprocess.list2command-line. Now, what if you want to go the other direction from a string into a list and you want to do proper command line unquoting of all of those quote marks? Well, this is one of those things that half the people seem to know and the other half never heard of. It's called shlex.split. It turns a quoted string into a nice little convenient list. And by the way, the shell actually does the quote handling, or under Windows there's a thing, but by the time that your main program in C sees it, argv and argc, it's already been split up into pieces. A program can't tell the difference between all of those because the quoting is handled invisibly to it. Thing number 2 is something called a LISKOV violation. There are these brainy eggheads who hang out on Python dev who like to throw around this term LISKOV violation, and you might be wondering what that is. Well, a LISKOV violation is a violation of the LISKOV substitution principle. This is a concept created by Barbara Liskov, a computer researcher. In a nutshell, if you have a type T and it has a desirable property P, and then you have a subtype of T called S, subtype S should also have property P. Said in one sentence, if you have a subclass that doesn't do something that the class does, then you have a LISKOV violation. So the classic example of this is the rectangle square problem. Let's say we have a rect class and we have methods on it called setWidth and setHeight. And then we have a subclass of that called square, because of course all squares are rects, but not all rects are squares. But we can't have setWidth and setHeight on those, because if you have setWidth, it's going to change the height. And the rect one doesn't do that. And if we don't have those methods at all, then again, that's something that rect does that square doesn't. So the classic solution for this particular problem is to invert it, so that you would have square be the base class and rect be the subclass, and then rect can have setWidth and setHeight. But in general, there is no general purpose solution to the LISKOV violation problem. Topic number 3, inconsistent submodules. So why is it that sometimes you can import a top-level module and then start using its child modules, its submodules, and sometimes you can't? This is actually pretty straightforward, although I wondered about it for years. It's just that the top-level module happens to import all of its children, and in the case of the email module, it doesn't. So the rule in Python is actually you should always import all of the leaves, all of the lowest level modules that you want to use. Finally, something called a morality tale of Perl versus Python. This is the last page of Programming Python 2nd through 4th editions. And this is actually from something posted on Rec Humor Funny in 1998. It's called A Morality Tale of Perl versus Python, and I'm going to perform it for you right now. Hold your applause. This has been percolating in the back of my mind for a while. It's a scene from The Empire Strikes Back, reinterpreted to serve a valuable moral lesson for aspiring programmers. Exterior, Dagobah Day. With Yoda strapped to his back, Luke climbs up one of the many thick vines that grow in the swamp until he reaches the Dagobah Statistics Lab. Panting heavily, he continues his exercises, grepping, installing new packages, logging in his route, and writing replacements for 2-year-old shell scripts in Python. Yoda speaks.
Code, yes. A programmer's strength flows from code maintainability. But beware of Perl. Terse syntax. More than one way to do it. Default variables. The dark side of code maintainability are they. Easily they flow, quick to join you when code you write. If once you start down the dark path, forever will it consume your destiny, dominate you at will.
Luke speaks. Is Perl better than Python?
No, no, no. Quicker, easier, more seductive.
But how will I know why Python is better than Perl?
You will know when your code you try to read 6 months from now.
The thing you didn't know is that I wrote that in 1998. Thank you very much.
Awesome. Okay, so we have Colin Deasy on deck. We have Jason Gores setting up over here. And please welcome Tendai, who's going to be talking to us about machine learning.
Hello. Hello, everybody. My goal is to convince you that machine learning is easier to get started with than you might think. Luckily, there's already been a good few talks this week which have done most of the sell for me. When we're talking about learning in AI, there's really 2 kinds of things we're talking about. There's regularity-based learning and there's reasoning-based learning. Techniques on the reasoning-based side have had limited practical application. A lot of the practical application of machine learning is on the regularity side. Identification trees, like a lot of techniques in machine learning, are not necessarily things which are invented by AI people. They have a large overlap with things which came before and after in statistics and other branches of mathematics. So, what is an identification tree? Well, with an identification tree, what you have is you have a bunch of data which is already classified, so you know which things are which in your data set. And what you want to use it to do, you want to use it to basically build a tree of yes-no questions, which you can then use when you pass a new data set through that tree. It will actually classify the unknown data items. So what kind of tree do you want to build? Well, trying to build all sorts of trees and see which ones work best is computationally infeasible. So generally speaking, you want to apply heuristics which result in a smaller tree. Not because a smaller tree is beautiful or because a smaller tree is necessarily intrinsically good, but the simplest explanation that explains the data is probably the most likely to be correct. The more contrived the reasoning, the less likely that sort of tree is going to have predictive value. So in our example here, we're using negative signs to indicate people who we know are not vampires, and positive signs to people who we know are vampires. So basically, how do you pick which question to put at the root of your tree? Well, essentially, you want to pick the questions which divide the data set as quickly as possible into homogeneous categories. And looking at the data set we have here, that would be the shadow test. It basically puts 3 people into the yes category and 1 into the no category, and 4 we still don't really know. What about the next question? Well, what you do is you take the data that's remaining from that, and you basically apply the same rule, but taking out all the data you've already classified. And when you do that with this particular data set, you get garlic, and you make that as your second node in the tree. Now, in this toy example, everything is now perfectly categorized, so we can basically stop developing the tree, and we can pass data sets through it. I have been saying you pick which data sets go into homogeneous categories. In a real data set, no question is going to put any of your data into homogeneous categories. So what you end up doing is just using the basically Shannon information theoretic measure of entropy, which is not actually that complicated. You can see anything near 0 there, which is where everything is perfectly homogeneous, has the lowest entropy. And on the other side as well, near 1, that's perfectly homogeneous, but in the other direction. So all those are good positions to be. The closer you get to the center, it means your data set is pretty much a bit of a jumble. So you don't want to use those questions first. You want to use the questions which are towards the edges of that graph first. So I sort of breezed by the numerical data we had in there. We had, I think it was income or net worth or something like that. How do you actually do a yes-no question when you have numerical data? Well, one thing you can do is you can just pick a threshold and just say if it's above this threshold, it's on this side. If it's above that threshold, it's on, or below the threshold, it's on the other side. That's not that great if you have a rich data set, because that's not usually going to be that great. Picking one threshold to do that is not going to be practical. You could say maybe I'll pick the negative threshold for somewhere in the middle for the negative things, or somewhere in the middle for the positive things. Again, that's not going to be that great. But this is a computer. We don't care how much work it has to do. You can pick many thresholds. You can pick them at random. That actually works pretty well. But what a lot of people do is they just pick thresholds which are in between all adjacent data sets. So if you have n data points, you end up with n-1 thresholds for the numerical data. And that usually works pretty well. I know you're all wondering, this sort of thing, is it web scale? Yes. No, but joking aside, building a tree can actually be a very slow process. It can take hours, days, weeks if you want. But once you actually have a tree built and you're running data sets through it, it's actually not very different to actually just running a bunch of if-else statements. So traversing the tree we have on the left there and pushing data through it is identical to the code we have on the right. And you would rarely ever ask if a series of if-else statements are fast. That's it. Go and do some machine learning.
Thank you, Tendai. So on deck, we have Radomir Dopieralski. And setting up over here, we have Colin Deasy. But right now, we'd really like to hear from Jason Gores as he teaches us about packages.
Okay, hello everybody. My name is Jason. I'm going to tell you about this package I developed. So as Fernando was describing this morning, the presentation here is running in the IPython notebook. You can see a rendered version of the slides at this URL later, because I'm going to go through this pretty fast to try and cover it all in 5 minutes. So I'm going to tell you first why I made this. Everybody here knows it's fun to build stuff, but the actual reason, so I do research in academia and like to play with the latest data analysis tools, stuff for machine learning and statistics. So a while back, I saw some new features being talked about for an unreleased version of a package that I wanted to try out. So did what most of us would do. I cloned the repo from GitHub. I knew I didn't want to install this dev branch system-wide, so installed it locally. Then fired up IPython to import, and no big surprise, it depended on a newer version of another package, which happened to be the dev branch of that package. So I repeat this process, go and install this other package, and now this one depends on a newer version of some other package, right? So this scenario is nothing new, of course, especially for developers testing new features across packages. So what to do, though? So automate, right? This is what we do. We're computer people. So at first, I wrote some shell scripts to handle this busy work, which worked. But then, of course, I wanted to do a little bit more, and the shell scripts became longer and uglier. So I took this shell script mess I had and rewrote it in Python, which has resulted in this package BEP, which is a package for managing bleeding edge packages. So this brings us to the present here. What exactly is BEP? BEP allows to install, update, remove, and list installed packages, which include repos from these different code hosting sites, as well as repos that you have on your local file system, Git repos, Mercurial repos, and Bazaar repos. You can also turn on and off already installed packages, and this makes it so that multiple versions of the same package can be installed side by side on the file system. So I'll tell you more about this in a little bit. So first, package installs. Packages are downloaded, built, and installed in the user's home directory, so no root access, no sudo, nothing like that's needed. And there are two ways to install. You can install lots of packages at once. I'm not going to talk about that here, but you can see that on my Git page where this is hosted. Or you can install them one at a time from the command line, which is what I'll be covering. So let's look at a few examples. Here's an example of installing IPython for the default version of Python. The command is somewhat self-explanatory. The stuff of interest is just up at the top, and the output is below. So you say BEP install GitHub IPython/IPython. So the first IPython here, that's the username on GitHub, and the second IPython, that's the name of the repository inside GitHub, or inside IPython on GitHub. Okay, so you could also install IPython under Python 3 using the language flag. So it's the exact same setup as before, but now we're specifying language equals Python 3. You could say Python 3.2, 3.3, you know, whatever. You could specify anything above Python 2.7. So if a package comes from somewhere that supports multiple repo types, like Bitbucket, you just specify that as well. So the syntax is very similar, but we're saying install Bitbucket, the username, the repo name of this repo, and we're specifying that's a Mercurial repo. We could say it's a Git repo if it were a Git repo. So that was installing. Now for updating, removing, turning on and off installed packages, they all follow a similar syntax, and there are two ways. The full syntax that's expected, or a shortened, nicer way. So to see these ideas in action, let's install another branch of IPython. First, we need to turn off the previous IPython we just installed. So you say BEP install GitHub IPython, and we're turning off the master branch here. Now we can install this other branch. This time is from the local file system where the desired branch is already checked out. So we're again saying BEP install, but now specifying a local repo. We provide the path to the repo, and this is a Git repo. And you can see down here, the branch that was checked out is the nbconvert branch. So that's what was installed. To see what we have installed, we use the list command. It just shows everything that we have installed, as well as if it's turned on or off. So the off packages are specified with this off star. And I said there were two ways to issue commands. Here's the simpler way. You simply say BEP turn off IPython, and it lists all the versions of IPython that are installed, where you specify the number corresponding to the one that you want to process. I think I'm out of time here, so you guys can check out the rest of this online. I posted the link at the beginning, but just to finish it up here, yep, okay, just to finish it up here, you could process all packages at once with an all flag, and I'm going to have to skip this. I just want to say thanks to certain folks, and here's the information.
Thank you, Jason.
To
Please,
check it out.
Thank you. So we definitely get it. IPython is amazing. I would almost want to see a talk on things you can't do with IPython, but it might be a short talk. We have, let's see, we have Jake Vanderplas on deck. We have Radomir Dopieralski setting up. And please join me in welcoming Colin Deasy.
Hello, everyone. So I'm going to talk about homebrewing. Beer and Python might seem like completely isolated entities, but to me, at least, they're not. I use Python quite a lot to automate parts of my brewing system, and that in turn generates some nice beer, which I consume and makes some Python look nice. So it's kind of a nice life cycle. The problem with homebrewing is that it's very manual. There's lots of parts that can go wrong and generate off flavors, and in general, every brew from one to the next can be different in lots and lots of different ways. Tastes like bananas, apples, all sorts of flavors. So it's quite useful if you can at least automate parts of that. I isolated at least, well, the main part for me was getting a constant temperature. So during primary fermentation, one of the most important things is having a constant temperature, at least at the start, for aerobic respiration, so that the beer can duplicate, or the yeast can duplicate really quickly. In Ireland, that's quite difficult to get an ale sort of temperature, which is roughly 21 degrees, depending on your strain of yeast. So to kind of keep it at that, it's an external heated system, so it heats a certain water supply and pumps it through the brew in the fermentation bucket. So to do all that kind of stuff, I use what is Raspberry Pi. It's kind of useful for a lot of things. There's some custom modules with that to kind of interface with some of the hardware components, but in general, it's pretty simple. The GPIO pins are quite easy to program against using Python due to the libraries that are available. That then feeds a bunch of server metrics so that when I go back to do the next brew, I can see, okay, at this point, the temperature seemed a bit wonky. Perhaps that was the banana, or something like that. In either case, that sort of metrics and logs makes it easy to kind of repeat it and keep consistent across brews, which is one of the hardest parts for a home brewery or micro-scale brewing, because it's just too expensive to kind of get that sort of automation otherwise. So for monitoring that temperature, there's a few simple sort of one-wire interfaces thermometers that you can use that give you pretty accurate readings. They're about five significant figures. I take readings for about maybe once every 5 seconds, that sort of thing, and store those metrics and then perform some operations based on those readings. So maybe I have to turn on a pump or a heater, or maybe I have to turn it down using PWM or something like that. But basically, it's all controlled from these readings. So if that fails, I'm kind of screwed. So yeah, I mentioned that it heats an external water supply and pumps it through coils within the fermentation bucket. I learned a few lessons with this. First, I bought a bunch of cheap components for about a couple of euros, which failed pretty quickly, actually. Also, it's kind of hard to build in redundancy into hardware systems, at least for me, because that's not my specialty. So when that fails, I'm kind of left empty-handed and wondering what to do at that point. So in the end, the pump overheated a few times for me, so I kind of limited the execution times for the pump, and the heating failed, so I had to replace it and all this kind of stuff. Another thing that happens so there's a bunch of ranges that I'm interested about, and there's a critical range outside of which I have to send alarms to me and other people who could possibly respond to this event. So it's quite easy to spam people when you don't think about that very easily, because it takes about 5 seconds to integrate with something like Twilio, to send text messages to you, your fiance, someone else like that, maybe. So when a component fails at 3 a.m., you don't really expect to be spamming people every 5 seconds. So I'm still getting married, by the way, which is a good thing. Yeah, so a part of my job is telling people how to integrate with our services about exponential backoff and this sort of thing. I really didn't heed my own lesson here. So yeah, as I said, it sends some metrics using graphite carbons. That sort of thing. So it's quite easy. Here, I have a nice little picture. So on the left is the on times for the heater. On the right, you can see two little blimps. The first one is when the pump failed. The kind of bump after that is me cradling it, trying to warm it back up. It kept on falling. The next one is when the heater failed again, and yeah, anyway, it was lovely stuff. So I had some fun doing that, but basically that means I kind of get a consistent kind of improvement over time. Yeah, that's me. Thank you.
Thank you, Colin. Okay, we have Kevin Verono on deck. We have Jake Vanderplas setting up over here. And please join me in welcoming Radomir Dopieralski.
Hello. So I'm going to whine a little bit about how hard it is to distribute a game once you write it in Python. But first, why would you write a game in Python, right? So Python is a nice language for fast prototyping, so it's perfect for game jams. There are some books that teach you Python by making you write games in it. And there is the Raspberry Pi, which is great for playing with and for writing games for, obviously. And you might want to teach kids in school based on games and stuff like that. And finally, why not, right? So there is a whole bunch of libraries and frameworks you can use to do that. Some of them actually have their own means of distribution, but most of them you will have to figure it out anyways. So the full list is at that URL on the Python wiki, so I didn't list all of them. Yeah, but sooner or later, if you want other people to play it, you are going to have to build a Microsoft Windows executable binary file, because they are not going to install Python just to play your game, right? Especially if it's a game jam and you want people to rate your game, to score your game, they are not going to bother if they have to install anything extra, especially if it's on a Mac where it's not so straightforward. So let's suppose you want to try and use PyTheX. There are several options that I have found. There's PyTheX, PyInstaller, CXFreeze, and Cython. I will talk briefly about all of them. So if you go to the Pygame wiki, for example, because you have made a Pygame game, and look for PyTheX, you will come up with this example code that you have to copy-paste from the wiki page. And it's supposed to do everything for you. It doesn't. It fails in strange ways, and it's, well, you can see it's pretty incomprehensible. So what you actually have to do is go to the PyTheX page and just proceed normally. And with some experimenting, I have managed to write this setup PY script that works for my particular project. But it's not really that good. There is one hack in it, as you can see, because I have to bundle additional files in it. And what's wrong with it? It's a copy-paste solution. So for each new project, you have to copy-paste this setup PY and edit it a little bit to adapt it to your project. I didn't manage to make it work. The hack that adds the files, it requires you to actually run it from the root directory of the pen drive on which it is. It's hard to explain how it works, and you actually have to own and run a copy of Windows. So I have to borrow a laptop from a friend to actually compile it. So let's see how other languages, other frameworks do it. Maybe they have some better ideas. So there is this excellent game framework called Love2D. And basically, it's just a single executable. And when you are making your game, you just put it in a directory, name the files in a specific way. And when you want to run your game, you just type love and the path to that directory. And if you want to make a beta distribution of your game to just show your testers or whoever, you just zip it, rename it to .love, and they can also run it with the same love binary. And finally, you can append that zip file to the end of that binary, and you are done. That's your distribution. And why can't we do the same thing with Pygame, for example? So I have this project, PYTH, that actually does that. Thank you.
Thank you, Radomir. So we have Ping on deck. We have Kevin Verono setting up. And I just want to thank Jake for lending his laptop to two of our previous speakers. And he's here today because somehow he thinks that matplotlib and D3 would go well together. I thought Flash was the future, but please teach us differently.
Awesome. Well, as we found out earlier, IPython can do pretty much anything. And I'm going to tell you about something else that I've tried to make IPython do. So I'm Jake Vanderplas. I'm an astronomer at University of Washington. I work in a lot of scientific applications with Python. And I'm going to tell you about bridging matplotlib and D3.js. So if you haven't noticed, IPython is awesome. You can do lots of stuff in very few lines of code, embed graphics. But the problem is, when you embed a graphic like this, it's just a PNG, and you can't really do anything with it. It's not very dynamic. So a couple months ago, I decided to start tackling this problem, and I wrote a library called MPLD3. And in a couple lines of code, you can import MPLD3, enable notebook, show the figure, and then all of a sudden you have a dynamic view of it here. You can take this and zoom in and click the home button, go back. So this is really cool. And basically what's going on in the background here, it's really interesting. We wrote this MPL exporter package. I teamed up with the Plotly guys, if you've seen any of them in the expo hall. And what it does, oh, there they are. And it scrapes all the info from a matplotlib figure and outputs a JSON representation, which basically contains everything about the colors, the axes. It contains the data. It's totally human readable. You could go in and modify this if you want, but you don't need to because you have matplotlib. And this is interpreted by MPLD3.js, which is about a 1,500-line JavaScript library that I wrote. And this brings me to one of the truisms that I've found about data, about scientists in Python, is that scientific Python users love Python so much, they'll use Python for just about everything and write it every day. Scientific Python developers love Python so much that they spend all day writing JavaScript. That's how much we love it. This produces a pure client-side view of a matplotlib plot. So it means that you can basically embed it on any web page. You don't have any need to call back into the Python kernel. But there's a lot more going on here. You can I added this idea of plugins. So these are new interactive features that you can add to your matplotlib plots as long as they're embedded in MPLD3. So for example, if you want to know the labels of your points, you just create a list of labels, whatever you want them to be, and you create this plugin. I'm going to call it Point Label Tooltip. Connect it to my figure, and then when you hover over your points, it tells you what they are. So this is really flexible. You can do this with just about any plot type and any set of labels that you want. We can do more complicated things. Here's a long script that takes the iris data. Whoops, I clicked down. This takes the iris data from scikit-learn that some of you may have seen. And we add just a quick plugin, this linked brush plugin. Then all of a sudden you can do stuff like this. You can zoom in and scroll around and see how all these points are related on these multiple plots. So that's built in. That's kind of fun. And if you really, really want to get your hands dirty in this, and you're kind of a polyglot who loves Python and JavaScript, you can do things like define your own plugins by basically putting JavaScript strings in there. So here we're going to do one that highlights lines. So this is all the JavaScript that does the D3 highlighting. We just create a plugin object, and just like above, we can connect this object here to the figure, and then when we hover over the lines, it'll highlight them all the way through. So lots of possibilities here, and the development's been extremely active. I started this in December, and we've had about a dozen contributors. I'm doing the bulk of it right now, but we have a few really active folks who are doing some awesome work too. Great contributions. It's on GitHub. You can check out some more demos at mpld3.github.io. Find me on Twitter, JakeVDP, and if this looks interesting to you, we'd love to have you contribute and submit your ideas. So thanks.
Awesome. I want another minute of that. So we have Ping setting up over here. We have Josh Burkus on deck. And let's listen to Kevin Verono talk to us about security.
Hello, my name is Kevin Verono. I'm currently self-employed and do end-to-end contracting, which basically I handle a server setup as well as the web site development as well. And I've been dealing with various server security issues from time to time, and I've managed to find a good balance between security and that. And here are my thoughts and what kind of security practices I use. Okay, the basics. Install fail to ban. I'm sure everyone here knows about. It basically protects your server against SSH attacks and things like that, and mail server attacks and other things, right? And IP tables, I use that to block out. Say if I have an IP address like constantly on the log, just kidding me all the time, I tend to actually just block them out, which actually works pretty well. It just drops the packet, eliminates that problem entirely. And also disable password authentication in the SSHD config file. That basically eliminates the hacker from basically using like password, like dictionary attacks and things like that. And always try and use, well, always use, don't just try, always use private public keys to connect your SSH server. And then disable SSH version 1 and only use SSH version 2. And more basics here is to keep minimal set of packages installed, and configure and customize PAM. And I'll get more into PAM in 1 second in my next few slides here. Okay, and never allow root to log in via SSH. I cannot stress that enough. Like once they have the hacker, like root is the most known username out there for Unix systems. If the hacker's most likely going to try to attack the root account first because it's the most known account. So just disable root entirely in the SSH config file, and that should be good to go. Always have a personal account and just SU to root when you can, and never have admins share the same accounts. That's just not good practice. You can't really easily keep track of who's logging in and which accounts have been accessed at such and such times. And only give out root when absolutely needed. Like don't give all your sysadmins root if they don't really need that full access to the server. I would say just use sudo and give them access to specific commands that they would require access to. And also have a proper ITIL system in place to grant those admins access to those resources, or well. And offer simpler solutions. Use modularity when possible. An example of modularity of my own server is that I tend to separate all the services. Like I use Nginx for the actual web server, and then I have an application server for serving my Python apps. I use UWSGI, and then Django hooks onto that, and so everything is generally pretty much separate, and they're all separate users and processes. And if one service is exploited, then all the damage is limited to that one service, and you can easily recuperate from one service being damaged than your entire server being compromised. And configure PAM limits. This is the configuring PAM I mentioned earlier. Configure the etc security limits.config. This can protect against fork bombs by limiting resources to specific users. So if you know that certain processes don't really require a lot of certain programs don't require a lot of processes to run, you can actually limit how many processes that actual user can actually run. So if a hacker manages to get access to the system, they're limited on the amount of processes they actually can execute, so it kind of limits them from doing huge major damage or using up all your resources, for example. And my personal website, which I built in ncurses, because in ncurses website, when you access the site, it opens up a VT102 terminal literally in the browser, and it forks a Python process on the server to display an ncurses page, which is kind of cool, but anyways. And partition a hard drive, and if possible, but unfortunately most cloud offers don't allow that. I don't know why. So if you get a cloud service, you can't kind of separate your partitions because Amazon, AWS, and Rackspace and all that, they force you onto their partitioning scheme, so you're kind of stuck. But you can use a loop file system, and if you can do the mounts, you can actually, I would recommend saying /home var and temp. Should be no executable, no SUID, and no devices, because hackers can obviously use those to exploit other resources on your server. And that covers everywhere normal users should be able to write. And if you want to go to the extreme, this is very extreme, but it's funny. In a Linux environment, it is very well possible to mount the entire root file system as read-only and nothing or during normal operation. So in theory, you can mount your entire server file system as read-only and only allow read-write during maintenance windows, such tasks as updating the system. And taking it to the next level, if you're really super paranoid, you can just build a live image and run your entire server in RAM and just use read-write to your database or other parts you actually need read-write to. Otherwise, you can keep this entire system in RAM, which has the other side effects too, which gets to the side effects here. I think I'm almost done with 5 minutes, so this is yeah, Finn. Thank you very much.
Thank you, Kevin. So we have Josh Burkus setting up over here. I guess I need a microphone to speak. So we heard at our lightning talks last year about 2 very short modules. So I just want to check how many people, well, we heard about hi last time. I noted that one. And then we also learned about Q. How many people use the friendly logging for tired programmers, Q? Okay, so the author of Q is here to talk to us about Google Crisis Map. So please put your hands together for Ping.
Thanks. Thanks. Hi, my name is Ping, and I work at Google on the crisis response team. And our job is to get critical information to people to help those who are affected by natural disasters. One of the tools we use is called Google Crisis Map. It's a Python app running on App Engine that we use to publish maps. This is a tool that I hope you will never have to use, but I'd like you to know about it for 3 reasons. If you are affected by a disaster, then you may be using it to view these maps. You may find yourself in a position to volunteer and maybe help create or publish these maps to help your own community or help communities affected by disaster. And if you're interested, it's an open source project and you can contribute. So our team responds to several disasters every year. This is the map that we published using Google Crisis Map for Hurricane Sandy. This is a map we published for Typhoon Yolanda. This is a currently live map showing information about wildfires in the United States. Google Crisis Map doesn't host the data for these maps, the locations of all of these points. It's actually a mashup tool. It allows you to combine layers of data from other sources and layer them together to make a map. So in this case, for example, we're getting information about shelters from a feed from the Red Cross. There's information about fires from a KML file on the USGS site. There's a layer down here with information about air quality that comes from the EPA. So a couple of interesting things happened that I want to tell you about in the last year of development on Google Crisis Map. The first is that we now let you publish your own maps. So it's not only our team at Google that can publish maps now. We want people to help us make maps for their own purposes affected by communities affected by crisis. So I'm going to walk you through how to do that. When you create a map, you need to agree that you're creating it for a crisis or humanitarian purpose, or that you're a nonprofit. When you create it, you get, so here's a blank map. There's no layers on it. And I'm going to pretend that there's an incident that's happened in Montreal. So I'm going to zoom in on Montreal here. There we go. And I'm going to title this map Emergency in Montreal. OK. And I'm going to add a couple of layers of data to this map so you see how that works. I'm going to add a KML layer. So here's the City of Montreal's website, and they have a KML file with information about emergency water sources. So here's a URL to that. Oops. Here's the URL to that file. And I'm going to entitle this Water Sources. And so the data is being pulled in from that site live, and now here's that data from that site showing up. So it's maintained by them, right? It's an incoming live feed. If they update that file on their website, it's going to update automatically here on this map. I'm going to show you other types of layers we can add. So in addition to KML, we can support GeoJSON, GeoRSS, image files like tile surfaces, and also CSV files. And Google Spreadsheets are an interesting example I'm going to show you now. So here's a Google spreadsheet with some hospitals and their locations, their lat longs. So to publish this on the map, I just need to publish to the web, start publishing this layer, and then when I take this URL onto the map, OK, I'm going to configure which columns of the spreadsheet contain the name and the lat and the long. And I can set the icon that I want to use for these points. And this is going to be a layer of medical aid. OK, great. So when I add this layer, you'll see in a moment. You should see in a moment the information from that spreadsheet showing up. I probably mistyped something. Yeah, no, that's intentional. You'll see in a second. I have one I prepared earlier, of course. So this is what it shows up when the information from that spreadsheet shows up on the map. What's interesting about it, of course, is you can collaborate on Google Spreadsheets, right? So you can share that spreadsheet with other people. They can add rows to that spreadsheet, edit it, and those edits will show up on this map. The other interesting thing that we did is we made it possible for people to comment on points on this map. So the way you do that is by adding topics to this map. So I'm going to add a topic for medical aid. And I'm going to allow people to comment on this medical aid layer and add a question asking people whether that hospital is currently accepting patients, because we want people to be able to update this information in real time if they're on the ground and be able to see that. OK, so having prepared this map, I can now save it and publish it. And that produces a map that users can see. And when users click on these points, they can comment on them and update those points for other users to see. This is an open source project. It's hosted on Google Code. If you're interested in building maps, publishing them, or if you're interested in contributing to the project, please contact me. Thanks a lot for listening.
Thank you, Ping. I'd like to welcome our final speaker for the evening, Josh Berkus, who's going to be speaking to us about the 7 deadly sins of software deployment.
A long time ago, in my DBA youth, I wandered the web, looking for truth. On a secret server farm, lonely and bleak, found I the angel of truth I did seek, a radiant figure whose name it was Nuth. The angel Nuth granted me my desire, taking me on a journey through routers unknown, to a cold black gateway, fearful and dire. Written upon it gleamed words made of fire. Through me pass into the sight of downtime. Through me pass into eternal overtime. Through me pass and moan ye in fear, all updates abandon ye who enter here. Beyond the gateway lay tortured hordes, DBAs and ops staff condemned for their sin. Quoth Nuth, here is truth. Let us begin. In the first circle were fat, lazy slobs, whose high inertia had cost them their jobs. To coworkers' grief and great frustration, they wrote neither scripts nor documentation. Why do you need deployment scripts? That's too much work to get done. I'll just run the steps by hand. I know I won't forget one. And the same for change docs. Wherefore do you task me to find out how each step works? When you need to, you just ask me. They each receive for their just reduction IKEA furniture without instruction. The second circle held parsimonious misers who listened only to financial advisors. Buy cheap staging servers. No one will know. They're not production. They can be slow. They need not RAM, nor disks, nor updates. Ignore you, QA, those greedy ingrates. That old prod server which did stutter and crash is just what the man ordered to save the dev budget some cash. Hard on the heels of these miserly fools, great slobbering gluttons farted and drooled. Stuffing their great maws, they greedily ate deployment requests and software updates. Install it, update it, do it ASAP. I'll have kernel upgrades, a new shared liber 3, a fat Python update and 4 new applications, and then for dessert, 16 DB migrations. These fat and these greedy condemned for sinful tricks to install Anaconda server on a 286. In the third circle, awash with dramas, coded scornful sinner prima donnas. Need I no tests nor verification? Behold my code, kneel in adulation. Rollback scripts are meant for lesser men. My deployment's perfect as ever again. To each was assigned to learn what perfection really means by debugging outsource code from China and the Philippines. Moaning and thrashing, eyes bulging with lust for the new, were avid Reddit junkies. Only the cutting edge would do. On production servers, these wretches had deployed all of the most updated platforms and tools they enjoyed. New releases, alpha versions, compiled from source. No packages, no documentation, and untested, of course. Obsessed with the newest and shiniest to a degree most frantic, on an experimental flying machine, they must cross the Atlantic. These envious bastards each toot their own horn, treating coworkers with hatred and scorn. I cannot stand meetings, I will not do chat. My scripts are all perfect, you can count on that. I care only to clean my name. If my teammates fail, well then they'll take the blame. Since they like being lonely, eschewing chats, meetings, and talks, they are condemned to be mimes in a box. In the final circle are the sinners most dire, whose great wrath did consume them like fire. When failed the deployment, again and again and again and again they would try, frantically debugging each failing step on the fly. They would not roll back, but ground on all night. The very next time we run it, the upgrade will be all right. For this grievous sin, there was no penance worse to mend them than to let them keep trying to deploy the update which condemned them. You have now seen for your education and enjoyment the 7 deadly sins of software deployment. To escape DevOps hell, avoid sin, keep to heart these 7 virtues of an agile software art.
Thank you, Josh. I want to mention the PyLadies auction is going on now. There are other events going on, as well as just exploring Montreal. Please join us again tomorrow morning at 8:30 a.m. And please, let's give a huge round of applause for our wonderful speakers tonight.